Our next example says a bus travels 280 kilometers south along a straight path with average velocity of 88 kilometers per hour to the south. The bus stops for 24 minutes, then it travels 210 kilometers south with an average velocity of 75 kilometers per hour to the south. Notice we keep saying direction. That's very important. I want to start by drawing a picture of this situation. We move 280 kilometers south. Okay, so this is my initial position, and we're going at an average speed of 88 kilometers per hour. Then we stop for a while. Now when we stop, that means my velocity, my average velocity, or velocity in general, is 0. Now I'm going to write kilometers per hour because that's the units that the problem is using. And as long as everything cancels out nicely and there's no weird units left over, that's okay for me to keep it in kilometers per hour. And then I end up moving 210 kilometers south at an average velocity of 75 kilometers per hour. So here you can see there are 3 different chunks of time here. I'm going to say t here equals 24 minutes. Now I already noticed that there's minutes here and hours there. If I try to do any calculation with these numbers, they all have to be the same units regardless. So I'm going to be doing some converting. First we have to find, the question says, how long does the total trip last? Well, we know this chunk is 24 minutes, and I need to figure out how much time it takes me going at this velocity for this distance. So I'm going to use this equation. Velocity equals delta x over delta t. And because it's asking how long, that tells me I'm looking for time. So I'm going to rearrange a little bit. I'm going to multiply both sides by delta t. And then I'm going to divide both sides by the average velocity to get that velocity to cancel out. So notice now I have an equation for delta t just by rearranging those variables. It's delta x over our average velocity. So my time here is going to be 280 kilometers over 88 kilometers per hour. Now you know in math class that if you have a fraction in the denominator, that this is the same as multiplying. So this hour ends up coming up and the kilometers will cancel. So if I do 280 divided by 88, I get 3.18 hours. So I'm going to put delta t, and I'm going to label this delta t1 to signify that it's for the first section. Delta t1 equals 3.18 hours. Delta t2 then would be this 24 minutes. Let's go ahead and put that in hours. Well, I know from physical science that I need to do a conversion factor. If I want minutes to go away and hours is what I'm left with, I have to put hours on the top. So what's a conversion factor that relates minutes to hours? Well, I know that there are 60 minutes in 1 hour. So I'm just going to do 24 times 1 divided by 60. The minutes cancel and I'm left with the unit I need. 24 divided by 60 is 0.4. Alright, 0.4 hours. Now, to find the time here, I don't have to do this math over again because I know it would just be the same thing. I'm going to say my third time for the third part of this problem equals delta x for this part of the problem, which is 210 kilometers, over my average velocity, which is 75 kilometers per hour. Now we need to mark out our kilometers, and we're left with hours in the top. So my delta T3, my time for the third part, is going to be 210 divided by 75, 2.8 hours. So if we take 3.18 plus 0.4 plus 2.8, we get very close to hopefully 6.4. Let's see, 2.8 plus 3.18 plus 0.4, 6.38, which is very close to 6.4 hours. So my total time equals 6.4 hours. Now the second part says, okay, well, let's find the total average velocity. Total average velocity is total displacement over total time. We don't care that we stopped. We don't care that we go backwards. We don't care that we go faster here versus faster there. We need to find a total displacement divided by total time. So I'm going to write my average velocity, and I'm going to put the subscript total, so I know I'm talking for the entire trip. Is going to equal my total displacement over my total time. So my total displacement is going to be 280 kilometers plus 210 kilometers. Oh, you can't see that. Let me move my face. Sorry. 280 kilometers plus 210 kilometers divided by the total time, 6.4 hours. Notice these units. If I add kilometers and kilometers, nothing cancels. So I get, let's see, 280 plus 210 is 490 divided by 6.4, we get 76.6, or let's just round that to 77 meters or kilometers per hour. So my average velocity for the total time is 77 kilometers per hour.